So as shown on this base map, the city of Dublin, Ohio's 120-mile double-link infrastructure is located throughout central Ohio, and it was built to ensure the rapid deployment of competitive and redundant broadband services while also protecting our right-of-ways. It also established a city-owned fiber optic network. We established the Central Ohio Research, or CORN, not something you eat, but we established it in partnership with the Ohio Academic Resource Network and its 100 gigabit per second backbone to provide connectivity between businesses, public networks, and the Ohio Supercomputer Center. And Doublink also provides the backbone for our 24 square mile Wi-Fi system operated by high-speed air. The city allows businesses in the community to use its dark fiber for the purpose of operating their own IT backbones and experiencing significant cost avoidance. And because of Doublink, the city has experienced the addition of over 10,000 jobs. It's saved $4 million over 10 years by operating its own IT backbone, and it will earn $2.2 million in revenues through dark fiber lease arrangements. Doublink and broadband are the cornerstone of the city's economic development program, earning the city global recognition as a top 7 community by the Intelligent Community Forum in both 2010 and 2011. And the city of Dublin is proud to be a U.S. Ignite city. We're now leveraging Doublink infrastructure to provide a vital suite of services to bridge the digital divide for our smaller companies. These services will provide access to thin client services, to our Wi-Fi, to data analytics, high-speed internet services, data center services in partnership with Metro Data Center, and, as I mentioned earlier, connection to Ornet's 100 gigabit per second backbone, which allows Dublin's businesses, like TotalSim, to directly access the incredible computing resources available at the Ohio Supercomputer Center. So now I'd like to introduce TotalSim President Ray Leto, who will give an overview of the Doublink US Ignite project.
So a little background, TotalSim USA was formed in 2009 as an offshoot of a UK company of the same name. Along with myself, my business partner Nathan Eagles, we're both aerospace engineers with a motorsports background. Nathan with over 10 years in Formula One and myself with 25 years in IndyCar racing. In motorsports, we use the latest advanced engineering techniques to compete on a weekly basis. And over the last decades, this has meant modeling and simulation. Of course, in racing, we're spoiled with large budgets and motivated teams. Our idea in creating TotalSim was to take that motorsports mentality and methods of rapid product development and bring those to a broader range of industries. TotalSim specializes in computational fluid dynamics for automotive aerodynamics, but we also work in aerospace and many other industries, from HVAC to consumer products. As well, we develop and support an open source solutions for CFD, including the GPL licensed open foam. So there's something that major industries like major companies like Procter & Gamble, major auto and aerospace companies have known for a long time. They've developed a competitive edge using modeling and simulation in conjunction with supercomputing. This is also what we do in professional motorsports. Any place that there's large budgets and large teams of engineers, this is now the norm. But nationally, there's an issue providing the same competitive advantage to small and medium businesses, small engineering firms or manufacturers. These guys have local homegrown methods that do design and testing their own way. Typically, many of these companies are at the bottom of this stack, still doing only physical testing. That's where the Doublink US Ignite platform and Simulation as a Service app, developed by Prasad Calyam and his team in this project, in conjunction with Ornet's 100 gig network, the Ohio Supercomputer Center, all combine to help solve that problem and bridge that last large step. This is enabling us to become the leaders in an adoption of the next generation technologies in advanced manufacturing. Something I'd like to note, that when we were forming TotalSim, this infrastructure was key to our decision to locate in Central Ohio and specifically Dublin. So what do we typically do in our company? A virtual simulation starts by gathering the physical data, CAD data, build a model, and then we build the setup of the simulation from that 3D geometry on high-powered desktops. We then send off all the data required to run simulations to our local cluster or over the internet to an HPC center. This creates loads of data. Next, we analyze the data, creating reports and flow visualizations. Then we have to deliver this to the customer. Typically, we go around this loop many times within a project. The cumbersome part here is the communication and the data transfer. Currently, we snail mail DVDs, send giant emails, use FTP. We talk on the phone, maybe use a WebEx if we can. Anyway, it's all very, very slow on the regular internet channel. So here's the new way we see to work that will leverage Doublelink Ignite platform and the SMAS app that was seed funded by the Mozilla Ignite Challenge and VMware here. Okay, we have a customer that lives on the internet. If they're lucky, they have a fiber connection. If they're super lucky like us and they're in a Dublin, in a US Ignite city like Dublin, they have a really fast Ornet connection. Either way, they upload or simply link their data using a cloud service like Box.net or Dropbox. TotalSim accesses the client's uploaded geometries directly or via a thin client. Then we create the simulations. Next, we submit those simulations to OSC's supercomputing system, which has over 200 teraflops of computing power and 2 petabytes of storage. That's where the customer simulations are crunched and the data stored. We also have routines that automatically post-process the data, create reports, and visualizations. For us, these simulation results are very large, 10 gig per simulation. Some simulations we run are as large as a half a terabyte per simulation. Finally, and this is the cool part, through the SMAS app, we can share these solutions over next-gen thin client protocols that use gigabit networks powered by software-defined networking and Genie technologies. This could be a raw data file, a rendered video, or even something as simple as an Excel spreadsheet. But it's all in a secure, collaborative environment with optimum user experience. The secret sauce is that the giant data, heavy computing, and rendering stays on the big computers that live on the fast network. The SMAS app created by Prasad Calyam's team in this pilot makes the virtual desktop super fast, yet completely secure. Way better user experience than old VNC or other remote clients. This is a video of logging in to the Doublelink Ignite portal. User can log in using any connected device, laptop, tablet. We'll come up to the Doublelink Ignite desktop. Then the Horizon app portal, where we can place any SIM apps, Box.net, things that you may want to use, ParaView. And then we also have software installed like ParaView that the customer can use. We can have that all set up so that this VM spools up exactly like we want it to for the customer. Over on the live demo screens, Alex Berryman is spinning around a real simulation right now. That's an actual login to one of these desktops. You can see that I'm logged into it through WebEx to communicate with the customer. We're looking over this giant piece of data from the truck portal. So we can do this, or we can show really large rendered videos like the one you're seeing there. This is the future of modeling and simulation, and we're not the only ones that think so. This animation that you see is from a project that Ohio Supercomputer and TotalSim completed with funding from the U.S. Department of Energy through the National Center for Manufacturing Science. There are many groups like the DOE, and as Matt mentioned in his keynote this morning, the Endemic program, which we were a small part of as well, that are funding work to facilitate easier use of HPC in the manufacturing supply chain. Just in the last couple of weeks, Ohio Third Frontier Commission approved a $6.5 million public-private partnership project called IntelSim that involves OTEC, P&G, Intel, ourselves, and a couple other small companies like us to develop an app-building software infrastructure to realize the promise of pilot projects like we've seen here in this Ignite project as well. Thanks for your attention.